Hello, in this lecture we'll find out the area of a circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have a circle. In addition, we know that side AB equals to 2 units in its length, side BC equals to 8 units, side DC also equals to 8 units. This is angle ABC that is equals to 90 degrees in its side, and this is angle DCB that is equal to 90 degrees. Again, our mission is to find out the area of this circle. In order to find out the area of the circle, we will do a construction. That is to say, we will extend side DA and side CB of this quadrilateral by a straight line until they touch each other. So this is the touching point of the extended side DA and side CB. We define the touching point as M. We define this angle as theta, and we'll focus on the right big triangle, triangle MDC. On the right big triangle, triangle MDC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Okay. CB is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended the straight line CB by straight line, and the result is CM. When we extend a straight line by straight line, the result must be a straight line, so CM is also a straight line. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees, plus the missing angle that is actually angle ABM. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees. So, in the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. So I write it down. In the next step, we prove that the right big triangle DCM is similar to the right small triangle, triangle MBA. So I write it down. We prove that the right big triangle, triangle CDM is similar to the right small triangle, triangle MBA. So, why those two right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle DCM in the right big triangle CDM, and it is equal to this angle, that is actually angle ABM in the right small triangle MBA. Repeat again. Angle DCM in the right triangle CDM equals to angle ABM in the right triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself, it's a common angle that belongs to both triangles. So if we relate to this angle, angle theta, as it belongs to the right big triangle CDM, it will be defined as angle DMC. And it equals to itself. So if we relate to angle theta as it belongs to the right small triangle, triangle MBA, it will be called angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle CDM in the right big triangle CDM, and it is equal to this angle, that is actually angle MAB in the right small triangle MBA. Okay, so repeat again. Angle CDM in the right big triangle CDM equals to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the fringes of the right big triangle DCM are correspondingly equal to all the fringes of the right small triangle, triangle MBA. Therefore, we actually proved that the right big triangle CDM is similar to the right small triangle, triangle MBA, according to angle similarity rule. So write it down. We actually proved that the right big triangle, triangle CDM is similar, this is the sign of similar, to the right small triangle, triangle MBA, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. that side DC of the right big triangle CDM over side AB of the right small triangle MBA equals to side CM of the right big triangle CDM over side BM of the right small triangle MBA. Repeat again. We graph that BC over AB equals to CM over BM. DC, this side DC equals to 8 units in its length over AB. AB equals to 2 units in its length. And it is equals to CM. From the drawing itself, it's very easy to see that CM in total equals to CB plus BM. That is to say, CM equals to CB, that is 8, plus BM, that is the missing side. So in total, CM equals to 8 plus BM. So we substitute CM here by 8 plus BM, and we have to divide it by BM. In conclusion, found out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM, and we get that 4 times BM equals to 8 plus BM. Here we'll subtract BM from this equation, and we get that 4BM minus BM is 3BM, that is equals to 8. Here we'll divide this equation by 3, and finally we'll get that the missing side BM equals to 8 over 3 units in its length. Side BM, this side BM equals to 8 over 3 units in its length. In the next step, we'll focus on the small right triangle MBA, and we'll implement on this right triangle the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle MBA is AM, therefore the square of the hypotenuse is AM squared. That must be equal to AB squared plus BM squared. Repeat again, according to the Pythagoras theorem in the right triangle MBA, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BM squared. BM is 8 over 3, therefore BM squared is 8 over 3 squared, that is actually 64 over 9. In conclusion, found out that AM squared equals to 4 plus 64 over 9. So AM squared equals to, here we have 4 plus 64 over 9. So we multiply 4 by 9 and then we divide it by 9 in order to overcome factor with 64 over 9. So 4 times 9 is 36. So in total, in the numerator of this expression, we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So in conclusion, we found out that AM squared equals to 100 over 9. Here we take a root out of this equation and finally we get that AM equals to the square root of 100 over 9. So the square root of 100 over 9 is the square root of 100 that is 10 over the square root of 9 that is 3. So in conclusion, we found out that the length of the hypotenuse AM is equals to 10 over 3 units. So write it down in the original drawing that the length of the hypotenuse AM is 10 over 3 units. AM equals to 10 over 3 units in its length. In the next step, we will do another construction. That is to say, we will draw perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. It is absolutely possible because we have here infinite points on BC. In each point we can draw perpendicular. So we will find the point that will also create tangent to this circle. Okay. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular inside BC as T. We will define the point of tendency of the perpendicular with the circle as K. In the next step, we will extend the perpendicular TK until it touches side AD. And we will define the touching point of the extended perpendicular TK with side AD as point S. Okay. So by doing this construction, we created the right triangle MTS. Inside this right triangle MTS, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay. In the next step, we'll define the center of this circle, this point as O. We'll define the point of tendency of tangent AS with this circle as G. We'll define the point of tendency of tangent AB with this circle as N. And finally we will define the point of tendency of tangent BT with this circle as L. Actually, we don't need this point, so we delete it. In the next step, we'll join points O and M together by a straight line. Point O is the center of the circle, point L is the point of the circle itself, therefore OL is the radius of this circle. We will define the radius of this circle as x, therefore OL equals to x. This is the radius of the circle. So you can actually implement here rule 1. We'll repeat quickly rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. In the drawing we have a circle and we have this is tangent AB, that is tangent to this circle is point M. Point M is the point of tendency. And we have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals 90 degrees and this angle also equals 90 degrees. We can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius OL that is drawn to point L, that is the point of tendency of tangent BT with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius LO. If BT is perpendicular to LO, it means that this angle equals to 90 degrees. This angle also equals to 90 degrees according to rule 1, of course. In the next step, we join points O and K together by a straight line. Line segment OK is the radius of this circle. According to our definition, the radius of this circle is x. Again, we have the radius OK that is on to point K, therefore according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and N together by a straight line. ON is the radius of this circle that is equal to x. Again, we have the radius ON that is on to point N, therefore according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. In the next step, we'll focus on the small quadrilateral OKLT. In this small quadrilateral OKLT, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees plus the missing angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. In order to complete the sum of the angles in this quadrilateral to 360 degrees, the missing angle must be equal to 360 degrees. So, inside quadrilateral LTOK we have 4 right angles, and therefore we can relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OK equals to the opposite side LT in rectangle OKLT. But OK is x, therefore LT must be also equal to x. Likewise, according to the same rule, side LO must be equal to the opposite side KT. But LO is x, therefore KT must be also equal to x. So if we found out that LOKT is not a rectangle but a square. Likewise, we repeat on the same process in the small quadrilateral NOBL. This small quadrilateral. Inside this small quadrilateral we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So we can relate to this quadrilateral NOLB as a rectangle. Actually, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. Therefore, we can relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side NO must be equal to side BL. But NO is x, therefore BL must be also equal to x. Likewise, according to the same rule, side OL must be equal to side NB in rectangle ONLB. But OL is x, therefore NB must be also equal to x. Again, here we found out that quadrilateral ONBL is not a rectangle but a square. In conclusion, we found out that BT equals to x plus x, that is 2x. So, I write it down. The length of my segment BT is 2x. BT equals to 2x units in its length. In the next step, we will prove that the right middle triangle STM is similar to the right smallest triangle, triangle MBA. That those two right triangles are similar to each other. So I will write it down. The middle right triangle STM is similar to the smallest right triangle, triangle MBA. So, why those two right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is actually angle STM in the right triangle STM. And it is equals to this angle, that is actually angle ABM in the right small triangle MBA. Repeat again. angle STM in the right big triangle STM equals to angle ABM in the right small triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles. So we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to this angle, angle theta, as it is belongs to the right middle triangle, triangle STM, it will be defined as angle SMT. And it equals to itself. So if we relate to angle theta as it belongs to the right small triangle MBA, it will be defined as angle AMB. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, this is angle MST in the right big triangle STM, and it is equal to this angle, that is actually angle MAB. In the right small triangle MBA. I'll repeat again. Angle MST in the right middle triangle, triangle STM equals to angle MAB in the right smallest triangle, triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles of the right middle triangle, triangle STM are correspondingly equal to all the three angles of the right small triangle ABM or MBA. Therefore, we actually proved that those two right triangles are similar to each other according to angle similarity rule. So I write it down. We proved that the right middle triangle, triangle STM is similar, again this is the sign of similar, to the right smallest triangle, triangle MBA, and they are actually similar to each other according to angle similarity rule. And from the fact that the middle triangle is similar to the smallest triangle, we will derive that the following relationship exists between their sides. That side ST in the big middle triangle STM over side AB in the smallest triangle MBA equals to side TM of the middle right triangle STM over side BM of the smallest triangle MBA, and it is also equals to side SM of the middle right triangle STM over side AM of the smallest right triangle MBA. Repeat again. We conclude that ST over B equals to TM over BM equals to SM over AM. ST is the missing side, so we will leave it as it is, over AB. AB is 2, so we substitute AB by 2, and it is also equals to TM. What is the length of TM? From the drawing it is very easy to see that TM equals to x plus x, that is 2x, plus 8 over 3. So in total, Tm equals to 2x plus 8 over 3. So we substitute Tm by 2x plus 8 over 3, and we have to divide it by Bm. Bm equals to 8 over 3. And it is also equals to SM. SM is the hypotenuse of the middle triangle. SM, it is very easy to see from the drawing that SM equals to SA plus 10 over 3. Okay, SM in total equals to SA plus 10 over 3. So we substitute SM by SA plus 10 over 3, and we have to divide it by AM. AM equals to 10 over 3. So we can get this long equation. Those two sides are equal to each other. So we get the equation 1 from those two sides that are equal to each other. So according to equation 1, ST over 2 equals to 2x plus 8 over 3 over 8 over 3. So according to equation 1, we have ST over 2. On the other side of the equation, we have 2x plus 8 over 3. Here we multiply 2x by 3, and then we will divide it by 3 in order to have a common factor with 8 over 3. So in total, in the numerator we have 2x times 3, that is 6x, plus 8, divided by 3, and we have to divide it also by 8 over 3. We focus on this side of the equation 1. We have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. What is left from equation 1 after we cancelled 3? This side of the equation we left only with ST over 2. That is equals to the other side of the equation we left only with 6x plus 8 divided by 8. So here we'll cross multiply this equation 1, and we get that 8 times ST equals to 2 times 6x plus 8. Here we divide this equation by 2, And we'll get that according to equation 1, 8 over 2 is 4, so in total in this side of the equation we have 4st is equals to here 2 over 2 is 1, so we're left only with 6x plus 8. Here we'll divide this equation by 4, and finally we will get that st, the missing side st, equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in conclusion, we found out that st equals to 1.5x plus 2. So we can write down in the drawing itself that the length of side st of or line segment st, this line segment st, equals to 2 plus 1.5x units in its length. Is 2 plus 1.5x. We will continue to focus on the longer equation, this longer equation. Those two sides are also equal to each other, so we will create the equation 2 from those two sides that are equal to each other. So according to the second equation, or equation 2, we have those two sides that are equal to each other. So 2x plus 8 over 3 over 8 over 3 equals to SA plus 10 over 3 over 10 over 3. So actually this is equation 2, or the second equation that we created from the long equation. So in this side of the equation we have 2x plus 8 over 3. We will multiply 2x by 3 and then we will divide it by 3 in order to overcome factor with 8 over 3. So 2x times 3 is 6x, so in total in the numerator of this expression we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. Equals, in the other side of the equation we have SA plus 10 over 3. We will multiply SA by 3 and then we will divide it by 3 in order to overcome factor with 10 over 3. So it is 3 times SA is 3SA. So in total, in the numerator of this expression, we will have 3 times SA plus 10 divided by 3, and we have to divide it also by 10 over 3. So in this side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. In the other side of the equation 2, we have also 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. What is left from this equation 2 after we cancel 3 on both sides of the equation? In this side of the equation we left only with 6x plus 8 over 8. In the other side of the equation we left only with 3 times SA plus 10 over 10. So here we'll cross multiply this equation, equation 2, and we get that 10 times 6x plus 8 equals to 8 times 3sa plus 10. We will divide this equation 2 by 2, and you will get that this side of equation 2 we have 10 over 2 is 5. Inside the brackets we have 6x plus 8, and it is also equals to, here we have 8 over 2 is 4. So inside the brackets we have 3sa plus 10. So here we'll open the brackets on both sides of this equation 2, and we get that 5 times 6x is 30x, plus 5 times 8 is 40. That equals to 4 times 3sa is 12sa, plus 4 times 10 is 40. So here we have 40 on both sides of this equation 2. So 40 will get cancelled, and we left only with, so cancel 40, we left only in this side of the equation we have 30x. This equals, on the other side of the equation we left only with 12sa. So 30x equals to 12sa. Here we'll divide this equation by 12, and finally we will get that, according to equation 2, sa equals to 30x over 12 is 2.5x. So I found out that sa equals to 2.5x in its length. So I write it down in the original drawing. That this 9/7 SA equals to 2.5x units in its length. Okay. In the next step, I will copy this small quadrilateral ASBT in the new page with the circle that is inscribed inside it, and we'll analyze this quadrilateral ASBT. So actually this is quadrilateral ASBT with the circle that is inscribed inside it that I copied from the original drawing. First of all, we'll define the point of tendency of tangent AS with this circle as K. We will define the point of tendency of tangent AB with this circle as N. We will define the point of tendency of tangent BT with this circle as L. And finally, we define the point of tendency of tangent SC with this circle SH. You can implement here rule 2. I will repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the domain we have a circle, and outside the circle we have the common standpoint, point P. From the common standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, the length of tangent PA equals to the length of tangent PB, or PA equals to PB. So we can actually implement this rule 2 in our drawing. Why? Because if we focus on the common standpoint, point A, from the common standpoint, point A, we have two tangents to this circle, tangent AK and tangent AN. According to rule 2, they are equal to each other. So AK equals to AN according to rule 2. So if we define the length of this tangent AK as A, then the length of tangent AN must be also equal to A because they are equal to each other. So in conclusion, we found out that AK equals to AN equals to A. Likewise, we focus on the common standpoint, point B. From the common standpoint, point B, from this common standpoint, point B, we have two tangents to this circle, tangent BN and tangent BL. And according to rule 2, they are equal to each other. So that is to say, BN equals to BL. BN equals to BL. So if we define the length of tangent BN as B, then the length of tangent BN must be also equal to B because they are equal to each other. So we can write down here that BN equals to BL equals to B. In the next step, we'll focus on the common standpoint, point T. From the common standpoint, point T, we have two tangents to this circle, tangent TL and tangent TH. And according to rule 2, they are equal to each other, so TL equals to TH. So if we define the length of tangent TL as C, that is to say, TL equals to C units in its length, then the length of tangent TH must be also equal to C because they are equal to each other. So you can write down here that TL equals to TH equals to C. And finally, we focus on the common standpoint, point S. From the common standpoint, point S, from the common standpoint, point S, we have two tangents to this circle, tangent SK and tangent SH. And according to rule 2, they are equal to each other. That is to say, SK equals to SH. SK equals to SH, according to the same rule, rule 2. So if we define the length SK is D, the length of SH must be also equal to D because they are equal to each other. So we can write down here that SK equals to SH equals to D. In the next step, we will add side AD to side ST in this quadrilateral ASPT. So AB plus the opposite side ST. What is the value of side AB plus the opposite side ST in this quadrilateral ASPT? From the drawing, it is very easy to see that AB equals to A plus B, and ST equals to C plus D. Therefore, AB plus ST in total equals to A plus B plus C plus D. Likewise, we will add side AS to the opposite side, side BT. So what is the value of side AS plus side BT? From the drawing, it is very easy to see that AS plus BT, in total it is equals to A plus B plus C plus D. So AS plus BT also equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. So I write it down. So the expression AB plus ST, the expression AB plus ST equals to the expression AS plus BT because they are both equal to A plus B plus C plus D. Repeat again. AB plus ST equals to AS plus BT. Okay. AB equals to 2 units in its length, therefore we substitute AB by 2 plus ST. What is the length of ST? From the drawing it is very easy to see that ST equals to 2 plus 1.5x. Okay, ST equals to 2 plus 1.5x. So we substitute ST here by 2 plus 1.5x, and it is equals to AS plus BT. What is AS equals to 2.5x, therefore we substitute AS here by 2.5x plus BT. What is the value of BT? From the drawing, it is very easy to see that BT equals to x plus x, that is 2x. So we substitute BT here by 2x. In conclusion, we found out that 2 plus 2 plus 1.5x equals to 0.5x to 2.5x plus 2x. 2 plus 2 is 4. So in this side of the equation we have 4 plus 1.5x equals to, in the other side of the equation we have 2.5x plus 2x, that is 4.5x. So we found out that 4 plus 1.5x equals to 4.5x. Here we subtract 1.5x from this equation, and we get that 4 equals to 4.5x minus 1.5x is 3x. So in conclusion, we found out that 4 equals to 3x. Here we'll divide this equation by 3, and finally we'll get that x equals to 4 over 3 units in its length. So the radius x of this circle equals to 4 over 3 units in its length. Our mission is to find out the area of this circle. We know that the area of any circle equals to pi times the radius of the circle squared. The area of our circle, that is the area that we are looking for in this question, will be equal to pi times the radius squared. The radius is x, so the radius squared must be x squared. So the area of our circle is pi x squared. But we just right now found out that x equals to 4 over 3. So it is pi, if x is 4 over 3, it means that x squared is 4 over 3 squared. So in total, we found out that the area of our circle equals to pi times 4 over 3 squared. So it is pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. In conclusion, we found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. And that is the answer to our question. In the next step, I will summarize the lecture. In this lecture, we found out the radius of this. In this lecture, we found out the area of this circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have a circle. In addition, we know that side AB of this quadrilateral equals to 2 units in its length. Side BC equals to 8 units, and side DC also equals to 8 units in its length. In addition, we know that this is angle ABC that is equal to 90 degrees, and this is angle DCB that is also a right angle that is equal to 90 degrees in its size. Again, our mission is to find out the area of this circle. In order to find out the area of the circle, we did a construction. That is to say, we extended side DA and side CB of this quadrilateral until they touch each other. We define their touching point as point M. By doing this construction, we created the right big triangle DCM. On the right big triangle DCM, we define this again as theta. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. We know that CB is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended side CB by straight line. When you extend a straight line by straight line, the result must be a straight line. Therefore, CM, the result CM must be a straight line. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle ABM. In total, they must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. Okay. if this angle equals to 90 degrees, it means that triangle ABM is a right triangle. In the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Then we proved that the right big triangle DCM is similar to the right small triangle MBA. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself, it's a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we prove that all the three angles of the right triangle DCM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side DC of the right big triangle CDM over side AB of the right small triangle ABM equals to side CM on the right big triangle DCM over side BM on the right small triangle MBA. Repeat again, we will derive that DC over AB equals to CM over BM. DC is 8, AB is 2. And what is the length of CM? From the drawing itself, it is very easy to see that CM equals to CB plus BM. That is to say, CM equals to CB, that is 8 plus BM. So in total, CM equals to 8 plus BM. Here, CM equals to 8 plus BM over BM. So we found out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiplied this equation by BM and found out that 4 times BM equals to 8 plus BM. Here we subtracted BM from this equation and found out that 4BM minus BM is 3BM. This equals to 8. Here we divided this equation by 3 and found out that BM equals to 8 over 3 units in its length. Here this line segment BM equals to 8 over 3 units in its length. Then we focus on this right triangle, the right small triangle in BM, and we implemented the Pythagoras theorem on the right small triangle in BM. According to the Pythagoras theorem, in this small right triangle in BM, AM square equals to AB square plus BM square. Repeat again. In the right small triangle in BM, AM square equals to AB square plus BM square. So AM square equals to AB square. AB is 2, therefore AB square is 2 squared, that is 4, plus BM square. BM is 8 over 3, therefore BM square is 8 over 3 squared, that is 64 over 9. So we found out that AM square equals to 4 plus 64 over 9. So AM square equals to, here we multiplied 4 by 9 and then we divided by 9 in order to have a common factor with 64 over 9. So 9 times 4 is 36, so in total, in the numerator of this expression, we have 36 plus 69 divided by 9. 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So we found out that AM square equals to 100 over 9. Here we took a root out of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So in conclusion, we found out that the hypotenuse AM equals to 10 over 3 units in its length. The hypotenuse AM equals to 10 over 3 units in its length. Then we did another construction, that is to say, here we do perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular inside BC as T. We define the point of tendency of the perpendicular with the circle as K, and then we extended the perpendicular TK by straight line until it touches side DA. We define the touching point of the extended TK with side DA as S. And by doing this construction, we created this, the middle right triangle STM. In the middle right triangle STM, this angle equals to 90 degrees, this angle equals to theta, therefore the missing angle must be equal to 90 degrees minus theta. Then we define the center of this circle, this point is O, and we join points O and L together by a straight line. OL, point O is the center of the circle, point L is the point of the circle itself, therefore OL is the radius of this circle. We define the radius of this circle as x, therefore OL equals to x. We have here rule number 1. We have the radius OL that is drawn to point L, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BL will be perpendicular to the radius LO. If BL is perpendicular to LO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. We join points O and N together by straight line. ON is the radius of the circle that is equal to x. The radius ON is drawn to point N, therefore according to rule 1, this angle also 90 degrees and this angle also equals to 90 degrees. Then we join points O and K together by straight line. OK is the radius of this circle that is equal to x. The radius OK is drawn to point K, therefore according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we focus on the quadrilateral OK and T. The small quadrilateral OK and T. In this small quadrilateral we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So quadrilateral OKLT has 4 right angles, therefore we can relate to this quadrilateral as a rectangle. It must be at least a rectangle if not a square. So we can relate to this quadrilateral OKLT as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say OK equals to LT. But OK is x, therefore LT must be also equal to x. Likewise, according to the sum rule, OL must be equal to the opposite side KT in rectangle OKLT. But OL is x, therefore KT must be also equal to x. So we actually found out that quadrilateral OKLT is not a rectangle but a square because all of its sides are equal to each other. Likewise, we repeated on the same process on this small quadrilateral MOBL. In this quadrilateral NOBL, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Therefore, we can relate to this quadrilateral NOBL that has 4 right angles as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side NO must be equal to the opposite side BL. But NO is x, therefore BL must be also equal to x. According to the sum rule, side NB must be equal to side OL in rectangle NOBL. But NO is x, therefore OL must be also equal to x. So actually found out that quadrilateral NOBL is not a rectangle but a square. In conclusion, found out that BT, line segment BT equals to x plus x, that is 2x. Here, BT equals to 2x units in its length. Then we proved that the medial triangle STM is similar to the right small triangle MBA. What those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right triangle STM are correspondingly equal to all the three angles of the right triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that ST over AB equals to TM over BM equals to SM over AM. ST is the missing side, so we leave it as it is, over AB. AB is 2, so we substitute AB by 2. And it is equals to Tm. What is the length of Tm? From the drawing it is very easy to see that Tm in total equals to 2x plus 8 over 3. So we substitute Tm by 2x plus 8 over 3 over Bm. Bm equals to 8 over 3, so we substitute Bm by 8 over 3, and it is equals to Sm. Sm equals to Sa plus 10 over 3. So we substitute Sm by Sa plus 10 over 3 over Am. Am here. Am equals to 10 over 3, so we substitute Am by 10 over 3. So, in conclusion, we found out that St over 2 equals to 2x plus 8 over 3 over 8 over 3, and it is also equals to SA plus 10 over 3 over 10 over 3. Those two sides are equal to each other, therefore we get equation 1 from those two sides that are equal to each other. According to equation 1, st over 2 equals to 2x plus 8 over 3 over 8 over 3. Here, in this side of the equation, we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome factor with 8 over 3. So 2x times 3 is 6x, so in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. Okay, so here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After we cancel 3, we left only with st over 2, that's equal to 6x plus 8 over 8. Here we cross multiply this equation and found out that 8 times st equals to 2 times 6x plus 8. Here we divided this equation by 2 and found out that 8 over 2 is 4, so in total in this side of the equation we have 4st, and 2 over 2 is 1, so in total in this side of the equation we left only with 6x over 8. So in conclusion we found out that 4st equals to 6x plus 8. Here we divided this equation by 4 and finally found out that st equals to 6x over 4 is 1.5x. and 8 over 4 is 2. So in conclusion, we found out that st equals to 1.5x plus 2. Yeah. St equals to 2 plus 1.5x. Okay, then we continue to focus on this long equation. Those two sides that are equal to each other, so we get the equation 2 from those two sides that are equal to each other. So according to equation 2, we have here 2x plus 8 over 3 over 8 over 3 equals to SA plus 10 over 3 over 10 over 3. So in this side of the equation we have 2x plus 8 over 3. So we multiply 2x by 3 and then we divide it by 3 in order to overcome factor with 8 over 3. So 2x times 3 is 6x, so in total in this in the numerator of this expression we have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. On the other side of the equation we have SA plus 10 over 3. Here we multiply the SA by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. So 3 times SA is 3SA, so in total in the numerator of this expression we have 3SA plus 10 divided by 3, and then we have to divide it also by 10 over 3. So here we have this out of the equation 3 in the numerator and 3 in the denominator, so 3 will get cancelled. In the other side of the equation we have also 3 in the numerator and 3 in the denominator, so 3 also will cancel. So what is left from this equation after we've cancelled 3 on both sides of the equation? We left only with 6x plus 8 over 8, that is equals to 3sa plus 10 over 10. Here we cross multiply this equation and finally found out that 10 times 6x plus 8 equals to 8 times 3sa plus 10. We open the bracket on both sides of this equation 2 and found out that first of all we divided this equation by 2 and found out that 10 over 2 is 5. Inside the brackets we have 6x plus 8. Here 8 over 2 is 4, so inside the brackets we have 3sa plus 10. Then we open the brackets on both sides of the equation and found out that 5 times 6x is 30x plus 5 times s is 5 times 8 is 40. That's equal to 4 times 3sa is 12sa plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 gets cancelled. And we left only with 30x, that is equals to 12sa. Here we divided this equation 2 by 12 and finally found out that sa equals to 30x over 12, that is 2.5x. Here this line segment sa equals to 2.5x in its length. Then I copied the small quadrilateral ASBT in a new page with the circle that is inscribed inside it, and we analyze this quadrilateral ASBT. This is quadrilateral ASBT that I copied from the original drawing with the circle that is inscribed inside it. Here we can implement rule 2. According to rule 2, if you focus on the common extent point A, for the common extent point A, we have two tangents to this circle, tangent AN and tangent AK. And according to rule 2, they are equal to each other. That is to say, AK equals to AN. So if we define AK as A, then AN must be also equal to A because they are equal to each other. So in conclusion, found out that AK equals to AN equals to A. Then we focus on the common extent point B. From the common extent point B, we have two tangents to this circle, tangent BN and tangent BN. And according to rule 2, they are equal to each other. That is to say, BN equals to BL. So if we define the graph of BN as B, then BL must be also equal to B because they are equal to each other. So in conclusion, found out that BN equals to BL equals to B. Then we focus on the common extent point T. From the common extent point T, we have two tangents to this again, tangent TL and tangent TH. And according to rule 2, they are equal to each other. That is to say, TL equals to TH according to rule 2. So if we define the graph of TH as C, then TL must be also equal to C because they are equal to each other. So in conclusion, we found out that TL equals to TH equals to C. And finally, we focus on the common extent point S. From the common extent point S, we have two tangents to this again, tangent SK and tangent SH. And according to rule 2, they are equal to each other. That is to say, SK equals to SH. So if we define the graph of SK as D, then SD and then SH must be also equal to D because they are equal to each other. So in conclusion, we found out that SK equals to SH equals to D. Then we added side AB to the opposite side ST. What is the graph of AB plus ST? AB is A plus B and ST is C plus D. So in total, AB plus ST equals to A plus B plus C plus D. Then we added side AS to the opposite side BT. What is the value of AS plus BT? From the domain, it is very easy to see that AS plus BT in total equals to A plus B plus C plus D. So AS plus BT also equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. Okay? That is to say, AB plus ST equals to AS plus BT. AB is 2, and what is the graph of ST? From the domain, it is very easy to see that ST equals to 2 plus 1.5x. Therefore, we substitute AC by 2 plus 1.5x. And it is also equals to AS. What is the graph of AS? AS is 2.5x. So we substitute AS by 2.5x plus TB plus BT. What is the graph of BT? BT is x plus x, that is 2x. So we substitute BT by 2x. So in conclusion, we found out that 2 plus 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4, so in total, in this side of the equation, we have 4 plus 1.5x. That is equals to 2.5x plus 2x. 2.5x plus 2x is 4.5x. So in conclusion, we found out that 4 plus 1.5x equals to 4.5x. Here we subtracted 1.5x from this equation, and finally found out that 4 equals to 4.5x minus 1.5x is 3x. So in total, found out that 4 equals to 3x. Here we divided this equation by 3, and finally found out that x equals to 4 over 3 is inside. That is to say, the radius of this circle, x equals to 4 over 3 is inside. Our mission is to find out the area of this circle. And the area of any circle is pi times the radius of the circle squared. The radius of our circle is x. Therefore, the area of our circle will be pi times the radius squared is pi times x squared. Because the radius is x. But x is 4 over 3, so we substitute x by 4 over 3. And found out that the area of the circle equals to pi times 4 over 3 squared. Pi times 4 over 3 squared equals to pi and times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, thank you very much.